And guys, we're done. Okay? We've shown both case 1 and case 2 to be true, so then we can say by case 1 and case 2, we can say the absorption property for sets is valid. Okay? So we say, therefore, by case 1 and 2, A is indeed equal to A intersect A or B. All right, so these are a little bit sneaky because sometimes you have to pull some stuff out of thin air. Okay? So make sure that you guys know the definition of conjunction and disjunction. Okay? Like we said, for conjunction, okay, and I'll write this up here. You guys don't have to write this down. It might be helpful, it might not be. But if X is in A, then X could be in A or X be in any set. Okay. So this is the disjunction rule. Blushing, sorry. So that's our disjunction rule. The conjunction rule says that if it's in both sets, so conjunction says that if X is in A and B, okay, or we could say, I'll put a backslash here, X is in A and X is in B. We could say one of two things. We could pick whatever we want. We could say X is in A. We could say X is in B. Okay, either of those would be true. Okay, so that's a definition of a conjunction. Disjunction, we can build one. Conjunction, we can take either one or both if we wanted to. Okay, not necessarily, but it's not necessary that we have to. Right? Does that make sense, guys, for the difference now between disjunction, conjunction? Any questions about that, guys? Okay. Hopefully it makes sense to you guys just logically, okay? But if not, make sure you guys come and see me or email me so I can help you guys out with that. Okay, so now that we've proven a couple of these using the procedural definitions, and you guys can see how painful they are, okay? Remember what we did in class was we might have proven like one or two of the Boolean laws using the truth tables. Now we're going to be able to prove more difficult stuff using properties of sets. Okay? So much like when you guys had the Boolean stuff, okay, I'm going to give you guys a sheet with all the properties of sets on there. Let me hand that out real quick. I probably should have handed it out at the beginning, but there might be 8 in here, but if not, sorry about it. You just guess. There's a whole bunch in here. Yep, they're not all yours, by the way. You have to share it on. Okay, so I'll wait till everyone gets a copy of this. And then we'll go ahead and work some examples involving the set law stuff. By the way, a lot of these are going to follow the same sort of stuff that we did with the Boolean algebra. So for those of you guys that were really good with your Boolean algebra, this should be fairly easy to work with. Okay? But if you're not good with the Boolean algebra, then this might be a time for you to either A, get better, or B, get more frustrated with it. I'm not sure which one you'll hit, but hopefully one of the two of the good types. Okay? So we can use any of these properties now to be able to prove if I say using set laws. Okay, so I'm going to ask you guys to prove using the procedural definitions like we just did, and then I'm also going to ask you guys to do the set laws stuff. Okay, so let's go ahead and take a look at a few of those. Okay, so using the set laws, I want to prove that for any sets A and B, that A union set difference B minus A is equal to A or B. Okay, so the way that I look at these is, anytime you have a set difference law, use the set difference law immediately. Okay, I mean, you get a 1 point on the exam just for using set difference. It's the easiest one to do. Okay, so by set difference law, this is going to become A union quantity B intersect A complement. Okay, that's going to be equal to A. Okay, so that's just our set difference law. So does everybody see that, guys? It's the it's rule number 12. If you have B minus A, that becomes B and A complement. So in this case, I just have to put the A in the Okay, so that's our set difference law. eventually we want to make it look like A or B. Okay, so does anyone think they might have a suggestion for a law that we can use at this point? Bless you, Ben. And the good news is you have a 1 in 12 shot of getting it right, which is roughly an 8.3% chance.
Distributed?
Distributed, yeah. Guys, take a look at your distributive law. If you, and remember when we talked about Boolean algebra, if you have alternating signs, probably distributive is going to be the way to go. So this is exactly what the very first distributive law says. A or B and C, so we have A or B and A complement. So let's just make that work out with the distributive law. Okay, so isn't that going to be equal to, well maybe somebody can tell me, what's that going to equal to? A union B. So A union, what was it?
Complement.
A complement, nice. And then what goes in between here, guys? Intersect or union?
Intersect.
Intersect, nice. There we go. So, and that's going to be equal to A or B, hopefully. And that's by our distributive property. So does that make sense to everybody, guys? We have alternating symbols there, okay? And that's probably the easiest way to think of when do you use distributive versus associative. If they were all intersects, you could use associative, which would be really nice. Since one of them's a union and one of them's intersects, we have to flip those around. Okay. I'm hoping the next step is really obvious. Don, do you
I
have
just had a quick question.
Yeah.
The thing with the power, see, that just means anything that's not in A?
Correct, that's complement, right? So that just stands for everything that's not A, okay? All right, so take a look at your list now, guys. Okay, hopefully this one's really obvious. But if you have A union A complement, what's that going to be equal to?
Universe.
The universe, right? If I have whatever's in A and not in A, or not in A, that means I have the universe. And that's the complement law, isn't it, guys? Take a look at rule number 5. It spells it out specifically. A union A complement is universe. Okay, so this would become A union B intersect. Now here's what I'm going to do, guys. I know my U's and my unions look alike. So anytime I wanted to know universe, okay, I'm just going to put like the smiley face, like the McDonald's smiley or whatever it is, so that way you guys know I'm dealing with the universe and not the union between two sets. Okay, and I'll make sure I specifically do that each time. Okay, so that's going to be our complement law. Okay. I think we're just one away from being done this. Okay. Is there anything that says if you have a set and the universe, what that equals to? And if so, what is it? What's that going to boil down to? Yeah, guys, take a look at the identity law. Okay, if you have a set and the universe, so we have set and universe, it's equal to that set, right? In fact, we actually did those types of problems earlier when we did like the integers and the wholes and the reals and that sort of stuff. Okay, so this just becomes A union B, which is equal to A union B, and that's our identity law. And we're done. Does that make sense to everybody, guys? Any questions? Great.
Well, just a comment, I guess, rather. So because it's A or B is, I don't want to use the right. So because,
That's all right.
Because it's the intersection between A union B, between that and the universe, because the universe holds everything.
Correct.
You only need to keep that.
Correct, right. So this just means that, and you were talking about this, Greg? Or
Oh, no, I'm sorry about that.
Okay, yeah.
From complement to identity.
Gotcha, okay, yeah, because it means that, okay, well, if you have like a couple elements and you want to intersect them in the universe, you're not really losing anything.
You just keep those couple.
So you just keep that set, right. Okay, so that's what we mean by our intersection. Okay, John?
Do we not have to do like let A be equal set?
No, that's for the procedural definition, okay? Basically, John, what we did was we actually proved one of the commutative laws, and then we actually proved one of the absorption laws, okay? You would the only time you would use the procedural definitions is to prove any of these, okay? So, and on the examination, and a couple for homework, I'm going to say prove one of these laws using the procedural definition. Unless I say procedural or axiomatic, don't use that stuff. you would be here a very, very long time trying to use procedural axiomatic doing that stuff, okay? Yeah, we don't want to do that if we don't have to. Okay, other questions, guys? Okay, let's take a look at another one. Okay. A little more difficult, okay? If I have A minus B minus C, that's equal to A minus B union C, or hopefully it is. Okay. So, just like we did before, guys, what law do you think we should start with because
Set
there's minuses in
difference.
there? Set difference, okay? We gotta do that. Well, we don't have to, we did. So by set difference,
Chris,
yes, sir.
instead of set difference, because A has to be there, so why don't you do like associative and then do the set difference?
Can't do that there, because if you look at our sheet, we don't have an associative law that has to
Oh,
do with
okay,
minus
minus, I
symbols,
got it,
okay? So, now eventually we could, okay, but not yet. We have to turn it into the intersect and the union symbols,
Gotcha.
okay? So you're on the right track of thinking about it. I like how you're thinking about it. So this would be A intersect B complement, intersect C complement is equal to the right-hand side, okay? So that's just going to be our set difference. Okay. Mr. Art, can we use an associative now, sir?
Yeah.
Yes, we can, okay? We don't want to use distributive law because we're not using alternating symbols, okay? Now we just have an intersect and an intersect. So let's just move those parentheses around. Okay, so this would be A intersect quantity, B complement intersect C complement. Okay, that's just our associative property. And I know most people think the associative property is just one of those that you can always just assume and not write it out, but this one is extremely important that we do write it out. Okay. All right, anybody have an idea? And remember, we're trying to make it look like A minus B union C. Okay, so anybody have an idea as to perhaps what we could do with this? So, go ahead, Jake. Yeah, De Morgan's law. In fact, we use like reverse De Morgan's, right? We'd almost factor that complement out. Okay, so Jake, what would that look like, sir? A intersect quantity what? Any idea?
B intersect C complement.
And sir, instead of intersect, do you mind if I make it a union? Because we have to flip it around. Nice. So, that would be A intersect B union C complement. Good job. And that's going to be equal to, hopefully, the right-hand side. Okay, so that's our De Morgan's law. Basically, we just factored it out. And then,
Set difference?
yeah, set difference, right? Are we done? Because we have A intersect something complement. So anytime you have intersect complement, that's the very definition of what the set difference is. Okay? So John, would you write it as A minus the quantity of B union C? Again, guys, anytime that you have intersect complement, okay, all you guys have to do is just change that into set difference law. That's all that is. Okay, so this is our set difference. I think we're done, right? Because this left-hand side now looks identical to the right-hand side. Okay. So these first couple, like I said, if you're good with the Boolean algebra stuff, this actually follows the exact same. Okay, but if you're not good with the Boolean algebra, then unfortunately it's a little bit tough to do. Okay, go ahead, Ray.
Use these on the examination? or-
Yes, yeah. Just like with the Boolean laws, you guys are certainly allowed to use that as long as you don't write anything on there that would be beneficial. Okay. All right, other questions, guys? Okay, the next one is much more difficult than the first two, and I probably need about 15 minutes to do that, and I do have to return your guys' examinations, so let's stop here. I'm going to return the examinations to you guys, and that way if you guys need to ask me any questions about anything, you can, okay? If you guys want to, you can do almost everything on assignment 9, so what I might do is if you guys get some time, I'm sorry, assignment number 8. It'd be tough to do assignment 9 since we haven't learned anything on that. But assignment number 8, you guys can do almost all the problems. There's probably that last one that's going to be really difficult, so don't do that one yet. But that's going to be due next Monday. And is that the 31st?
Yeah.
Yeah, it's Halloween. Okay. great. I'll come in as a scary math teacher. Okay. Alright, so I do have your guys' examination, and I did return, I think it was assignment number 6. So let me give all those back to you guys. Just in case you're curious about the grade distribution for this, 6 A's, there were 8 B's, there were 2 C's, there were 4 D's, and there were 5 F's. So very bimodal distribution as opposed to the first examination, which was very skewed to the right. Okay. The average on the exam was 77.54 exactly, which is difficult to get an exact, but since there's 25 people in the class, it makes it really nice to divide by. So the standard deviation was actually around 10 as well, which is a really high deviation. So just in case anybody cares about any of that stuff. Okay, the first exam I didn't even put it out because everyone got easy things. Okay, so let me give these back, and then if you have some questions for me, let me know.